Loading. All right, welcome everyone to your Math 182 review for Professor Hernandez. My name is Carl. I'll be your tutor running this review session today. So this is a little interesting how we have some people in person for this review. And for those of you who are watching this at home on YouTube, feel free to pause whenever you have any and you need to look at any of the problems we do. For those of you in person, if at any point in time you guys have any questions, feel free to just like raise your hand, interrupt me at any point in time, however you want to go about it. This is your guys' review session. You guys take it how you want it, and you guys lead me and I'll help you guys out that way. So, and then again, just to clarify for you guys here, if for any of the problems you guys wanted to, like, for whatever reason, go back and look how we did it, it will be on our YouTube probably this afternoon at the earliest. And that YouTube channel, in case you didn't know, just go to YouTube. I have to stand up for this. It'll be YouTube, UNR Math Center YouTube channel. That's all it is. Really, really quick YouTube search. So it's this monitor is really frustrating. I can't see some of your faces, but yeah. So I have pulled up on here on the projector you guys' exam. So I asked you guys earlier, do you guys have any problems you guys wanted to start with in particular, or should I just start from the top and work our way down? You guys' preference. Any preference? No preference? Yeah, no worries. If you guys don't have any in mind right now, we'll go ahead and you do it later. Just let me know and we can work that way, all right? So we'll go ahead and just start from the top then. How many questions is this actually? So I have an idea. This goes down to, if it loads, 22 questions. Thank you. So 22, what about 55 minutes? Yeah, we should have enough time maybe to get to the end. Okay, so let's just start from the top. Question 1. We have right here, find the general indefinite integral you see for the concept of integration. So keyword here, indefinite integral always means plus c will be in your answer, right? So taking a look at this, what sort of process do you guys think you should do first in order to solve this problem? What should we do with this function in here? There's a few options. There's multiple different ways to get the answer, but what do you guys think would be the best way to solve this? Oh, is it not showing? There we are. That probably is important. Yeah. So what we want to sort of there's a few ways we can solve this. Like, for example, if you really wanted to, you probably could just solve it the way it is right now, but we're not that. There's an easier way to do this. What should we do with these two binomials here? Distribute them, right? So to actually factor and multiply them out. So if we quickly distribute this, we'll get the integral, well, let's simplify this. U times 5u is 5u squared. U times 3 is plus 3u, 10u, and 6. This is all du. So this simplifies further to, what's that? 5u squared plus 13u plus 6, correct? And then from here on out, if we were to go ahead and actually simplify this now, actually integrate it, what do? What rule are we using here? We're using power rule, right? So if we look at the first term, what is the sort of power rule when we do antiderivatives? What do we do to the exponent? We add 1, right? So we'll do 2 plus 1, which would be 3, but we also have to remember we have to multiply it now by 1 over the new exponent, right? So we're going to be multiplying it by 1 over 3, and then we had 5 to begin with, so I'm just going to write the 5 over there. Does that sort of clarify how I got that 5/3 u to the third? So doing the same sort of process over here, we'll write 13 there because it's going to be there. We had u to the 1 originally. We increment the exponent, so that'll be u squared, and we have to write that new power in the denominator, right? And lastly, same process. If we have a constant, that's technically u to the 0. So if we go ahead and increment that variable, increment the power rather, it'll become u to the 1. So this will be 6 over 1, right? And because this is, I should not have wrote the brackets, because this is a indefinite integral, we always have to remember this plus c at the end, right? So if we just sort of clean everything up a bit, it'd be 5/3 u cubed plus 13 halves u squared plus 6u plus c. That is our final answer. Any questions on that? So far, so good? That should be like a little warm-up to the whole thing, hopefully. So again, if you guys do have any questions, feel free to interrupt me. So let's go to question 2 now. Again, indefinite integral. So this one's going to be using a slight, I wouldn't say it's a trick, but a technique that can help simplify this problem to really easy. So we have this fraction where one thing's in the denominator, but multiple things are in the numerator. What is a technique you guys want to do that will make this problem easier? Is there any sort of things? Exactly, right? We can break up the fraction. So, for those of you online who couldn't hear that, we had one of your colleagues here said that a good technique is to break up the fractions, put an x under each individual part, right? And by doing so, we realize that some things become a lot easier to work with. So we have the integral of 8 over x. We can't really simplify that, so we'll leave that alone. We technically have x, the square root of x over x. Does anyone know what that simplifies to? It might be easier to write it as x to the 1/2 over x. We'll leave that alone for now. We'll come back to that. And then the last part, x over x, that's just 1. Very straightforward, right? So if we go back to that middle term, you can always write the square root of anything as that thing to the power of 1/2. And so that we have x to the 1/2 over x. What do we do to this? What does this become? What do we do to the exponents when we're dividing? We subtract, right? So then we'll have x to the 1/2 minus 1. So 1/2 minus 1 is just going to be x to the negative 1/2, right? And then we still have plus 1 there. Perfect. So now looking at all this, each of these individual parts, and now it's a lot simpler to take the derivatives of one thing at a time, right? Sorry, the integrals of one thing at a time. So looking at the first one, oh, sorry, I didn't mean to write that. Looking at the first one right there, we have the integral of 8 over x. Does anyone know how do we do this integral? So we have an 8, let's sort of break it up first. 8 over x. So we have a constant term. Whenever we have a number by itself, we can bring it out. I see someone who maybe has an idea. Exactly, right? You can pull the 8 out, make it 1 over x. And now what is the integral of 1 over x equals? So this is actually a special integral. I can tell you right now that if you're going to do the power rule, it is not equal this. It does not equal this because then you'll divide by 0. It does not equal this. This is not it. So whenever you have x to the negative 1 or whenever you have this right here, this is actually a special one. Does anyone remember it? ln x, right? Natural log of x, exactly. Technically the natural log of the absolute value, but yeah, we're not that particular. So it's actually equal to ln of x. So that means that the integral of 8 over x, or 8 times the integral of 1 over x, is just going to be 8 ln x, right? And that'll be that first term right there, what that simplifies out to. And as for the other two terms, that'll just be very straightforward power rule, right? All right, welcome, welcome. Just go ahead and take a seat. And we're currently on question 2. If you want to go ahead and just pull up the practice exam on your own device, if you can. And if you have at any point in time, if you have a question that you really want me to cover, let me know, and then I'll make sure I cover that first. All right. So to proceed back again, we've covered. We've covered. We solved for the first term. We know that the integral of 8 over x is 8 ln x. Now we need to do the rest. So the integral of x to the 1/2 plus the integral of 1. These are pretty straightforward. You just use our power rule right here, right? So you add 1 to the exponent. So negative 1/2 plus 1 becomes 1/2. And then you put 1 over 1/2. Right? You always put 1 over the new exponent. That simplifies out to 2x to the 1/2, or better yet, we like writing this as 2 root x, okay? And then as for the last one right here, the integral of 1, that'll just be x. Very straightforward. So putting all those pieces together, our final answer becomes 8 ln of x plus 2 root x plus x. And then what am I forgetting here? Plus c. Don't forget that. That is our final answer. All right. Any questions on that process? Should be, again, it's a little bit of a warm-up. The main thing, the main technique that is super useful in this case that we did in the start, breaking it up into separate fractions. And again, you can only ever do that. Well, I can't say only. It's mostly useful when you only have one term in the denominator and multiple terms in the numerator, right? Because then you can actually break it up and possibly simplify things. If there's like an x plus 2 in the denominator, that gets a little tricky. It might not be as easy to work with. But yeah, that's our sort of process right there. If there's no questions, I'll go ahead and move on to the next problem. So let's see. Question 3, still indefinite integrals. We're sort of reading through a long list, pretty good. We're doing in terms of t, the integral of t to the 7th, e to the power of negative t to the 8th. So just initial thoughts. What do you guys think we should do here? What sort of techniques should we use here? U sub, perfect. What would we let u equal then? Negative t to the 8th, exactly, right? And what was your sort of thought process? Why do you pick negative t to the 8th? Exactly, right? The derivative would be negative t to the 7th dt, and more importantly, there is a t to the 7th in our original function, which gives us the impression to use u sub. So excellent recognition right there. A general tip, if you ever see some complex things like this with exponents, if you ever see things to the power like x to the 8th and then to some e or whatever, and it's multiplied by the same x but an exponent less, that's usually a good hint it's going to be u sub. If you ever see one power but then there's another power one less than that, that's usually a huge hint, especially in cases, let's say, for example, um, we'll probably see an example of it coming up, but um, real quick, if I had x to the, let's say, 12 plus 2, and I had x to the 11th, the integral, this should immediately tell you u sub, right? Because I see a power inside a function, but I see one less of it outside. That's u sub in my head, right? So that's just an example real quick. Going back to the actual problem at hand now, what do we got here? So it's now going to be u subbing. Let's quickly solve for dt. If we solve for dt, we'll get dt is equal to du over negative du over t to the 7th, right? And now we can plug everything in. We'll have the integral of, oh yes, it's supposed to be 8 to the 7th. Good catch. Yes, so it'll be, yeah, exactly what you said. Perfect. Good catch there. Um, Now substituting everything in, if we quickly just do this, t to the 7th, e to the negative, well, we know t to the 8th, negative t to the 8th is u, so let's go ahead and substitute that in. And then we solve for dt. dt is right here, so we're going to be multiplying by negative du over 8t to the 7th. The t to the 7ths cancel out. All we're left with now is negative eu over 8 du, right? And because we have a constant term, we have a negative 1/8. Whenever you have constant terms, you can easily just pull it out because it's a lot easier to not look at it. So all we have left now is we pull out the negative 1/8 and we're left with e to the u du. And what is the integral of e to the u? E to the u, right? Exactly. So all we're left with is negative 1/8 e to the u, and don't forget, plus c. This is our final answer right there. I should write that better. That's fine. All right. Any questions on that process? That's just covering U sub. Good thing pointing that out. I almost forgot that. Yes. So I did forget that. You're right. So this answer is actually not the final answer. Whenever you have indefinite integrals, if you ever use sub, you always need to go backwards, which is what I forgot. So very good point. So this is actually not the right answer. We need to plug what we had for u back into our answer. So instead of negative 1/8 e to the u, we need to plug in what u was. And what u was, the answer will be negative 1/8 e. U was negative t to the 8th plus c. And this is our actual answer. Thank you for catching that. Very good catch. So the little note there that even I forgot, if you're doing indefinite integrals, then and you use sub, don't forget to go back. Forget to remove the u after, right? Always remember to go back and replace the u with what you substituted it with. So very good catch there. All right. Any other questions on that? No? All right. So let's go ahead and do number 4. We got another indefinite integral. And this is actually good. This is a slightly interesting one. We have a fraction, dx over 2x plus 3. Initial thoughts. What do you think we should do? You said, right? What would let u equal? 2x plus 3, right? And then if we take the derivative of that, all that becomes is 2 dx, right? So this is a little trick, well, a little thing to recognize. If the only variable power is x to the 1, and it's in a position that's not that good, so like the denominator, for instance, right? If it's like a binomial rather, and the variable is x to the 1, and there's no other powers left, then you can freely use u sub, because the derivative of x to the 1 is just the number in front, and dx will become du. Very simple, very straightforward, right? So if we go ahead and u sub this all now, we'll get real quick, dx will just be 1/2 du. If we go ahead and u sub this, we'll get, how do I want to write this? We'll get 1 over u times 1/2 du, right? Again, we can pull out the constant term, so let's go ahead and do that. And all we're left with is, if I can remember how to write, all we have left is 1 over u du. And as we covered in that previous problem, the integral of 1 over u, or 1 over x, is just going to be ln of x, right? Or ln of u in this case, plus c. But as we remembered in the previous problem, we have to remember to get rid of the u and go back to our original variable. So the real answer will be 1/2 ln. U was substituted as 2x plus 3. So it'll be the ln. Don't forget your parentheses. Very important. 2x plus 3. This is all what the ln is taking, and then plus c. This will be your final answer there, right? Yes, the absolute value of x. Another good catch. Yeah. Yes, the absolute value of x, not parentheses. Good point. Yeah, so it's technically the absolute value of u. I sometimes just remove it because in most cases, when you're working with definite integrals, usually the absolute values doesn't matter, right? But yeah, indefinite integrals, do not forget the absolute value. That's a very good point. Let's write that as a note. Ln of the absolute value. So don't forget these guys when you're working with indefinite, okay? So perfect. Let's go ahead and go on to number 5. Again, if you guys have any problems you want to jump to, we'll go ahead and do that. Actually, is it all right if I skip this one? This is going to be very similar to the previous. Because can you guys quickly guess what technique are we going to use here? U sub, and we're going to set what to it? Z to 7 plus 8, because the derivative of u is 7z to the 6, right? And from there, if we use sub, you'll get some answer. Do you guys want me to find the answer, or do we want to just go ahead and try to do the other problems? Good, if we move ahead? If we have time, I can come back and solve it. Does anyone really want me to solve it? No preference? All right. If we have time, I'll come back and solve it. But actually, I think I can figure it out right now. I think the answer becomes, ooh, uh, I think this is the answer right here. That should be the correct answer. You got it too? Perfect. Yeah, so if you guys go ahead and perform U sub, it should equal this in the end, if you guys wanted the answer. And again, if you missed the answer, don't worry, it'll be on YouTube later. So let's go ahead and go to number 6 right away. Evaluate the indefinite integral still. Now we're in trig functions. Okay, so this one you have to know your trig functions, how they cycle onto each other. We have cosine to the power of 8 theta times sine theta d theta. What are we doing here? What technique? U sub, right? Okay. Well, what are you U subbing? cosine theta, right? And the reason being, if you take the derivative of cosine, you get negative sine theta d theta. The key part here, sine theta d theta is what we have right here, right? That's how we can u sub it. So if we go ahead and, so this will just be negative du is equal to sine theta d theta. So this whole thing is right here. If we go ahead and sub it now, we have the integral of cosine to the eighth, so u to the eighth, and then again, sine d theta, we said right here, is equal to negative du, so this would be times negative du. So really we have the integral of negative u to the eighth du, power rule here, so we just increment the power, put it over that, and don't forget the negative sign, yeah? So it'll be negative 1/8 u to the ninth plus c, replace the u with what we had at the beginning, cosine 9 theta plus c. So far so good? Very straightforward, hopefully. These are very elementary trig subs in that there's no other tricks other than recognizing what you set u to, right? As if you can set u to the right thing, from there on it's just very simple algebra substitution, right? So I'll go ahead and leave that up for a bit if you guys want to write that down. Yeah, and again, if I'm going a little too fast and you want me to leave it on screen for a bit, just let me know, and then I'll pause for a bit. We got about an hour left. We're about, what, a third of the way in? Yeah, that's pretty good pacing. All right, so yeah, hopefully everyone's pretty much got it. Again, if you really want to write down all the steps, it'll be on YouTube later on. But as long as you kind of get the beginning part, the u sub, you should be able to solve it on your own. Just make sure you write down the answer as well so you can double check quicker. Right, so let's go to the next problem. Question 7. Here we are. Now we're into the big problems. We're doing actual sketches and curves and drawing. Okay, so sketch the region enclosed by these curves. Determine whether to integrate with respect to x or y. Draw a typical approximating triangle. Okay, so first, these types of problem sketching, it all just tests whether you know how to draw your basic graphs, right? So we got this first curve, we have a quadratic, y is equal to x squared minus 2x, and we got a straight line, y is equal to 2x. Let's get the easy one out of the way. So we know it's y equals to 2x. That's just a positive slope line. So it'll be something like this, right? Very straightforward. Y is equal to 2x is right there. Now this right here is a parabola. And real quick, is the parabola pointing upwards or downwards? Upwards, right? Because the number in front of the x squared is positive. So we have an upward shaped parabola. And now the bigger question is, where can we reference it? Well, little trick here. We don't have a plus c, so we can actually rewrite this as, we can take y of x squared minus 2x. If we pull out an x, we get x minus 2, x times x minus 2. And if you remember, this form is how we write the x-intercepts, right? So our x-intercepts are x equals 0 and x equals 2. So if we go ahead and write that on our points, here's 0. Let's say that this is 2. That means this is 4. Right here is where our parabola crosses the x-axis, right? So our parabola is something like this, approximately, right? This is how we write y is equal to x squared minus 2x. So this little manipulation of the thing, it will help you determine how to graph it easier. If you can find the two x-intercepts, perfect. That's 2 points. Just it's more than enough to sketch it. If you want to be more accurate, you could also try to find where the vertex of this parabola is, but I'm not going to bother. The two x-intercepts are perfectly enough in my books. But yeah, and then in case you needed to know as well, how would we solve for this point right here, where the parabola intersects with the line? We what? Exactly, right? We set the equations equal to each other. So if we want to find, technically we find both points of intersection, it'd be x squared minus 2x, the parabola, is equal to the line, 2x. So we go ahead and simplify this out. X squared minus 4x is equal to 0. we can factor out an x again. That'll be x minus 4 equals to 0. And then from here, we can see that it intersects at x equals 0 and x equals 4, right? So that makes sense with our graph at the origin. And this is, now we know that this is point right here is 4 comma 8. But yeah, all of that was a little unnecessary, but just a little, probably get a little ahead of ourselves. So we want to look for where the graph, actually before we find the graph, we also have to know how are we integrating this with respect to x or respect to y? Respect to y. So how would I draw my rectangle, vertically or horizontally? Horizontally. So you're saying like this? Vertically, right? So the way you can sort of tell how you want to do that is, let me get a different color. The way you want to, the way we figured out that we want to we want to do it with respect to y, is you want to pick the orientation where you have only one top function and one bottom function. So if that sort of rings a bell, if we look at here, if we draw sort of like a rectangle, oh, that's not the pen. If we sort of draw like a rectangle right here, if we take a look, we see that the rectangle hits only one top function and one bottom function, right? So if it's ever vertically like this is with respect to y, so this will be dy, right? Let's look at an example of what it would be if we looked at it horizontally, right? Because you might argue, well, if we look at it horizontally, like this, for example, there's technically only one top function and one bottom function, right? So that still works. But what if we go right here? If we go whole with respect to x right here, the top function and the bottom function are the same function, right? It's possible, but you'd have to change a bunch of stuff just to accommodate that, and we don't want to deal with that when we can easily do it with respect to y, where we only have to deal with one function on the top and one function on the bottom, compared to if we do it with respect to x. Once we try to do this region right here below the x-axis, we'd have to use the same equation. So the basic rule here is you want to integrate with respect to the variable that allows you so that the top function and the bottom function are two different functions. You do not want them to be the same function, because then you'd have to break that function apart, and that's too much work for us, right? Not in our pay grade. So that's the sort of reasoning why we want to do with respect to y, because at every single, if you draw a rectangle at every single area, so if we just draw a bunch of of yellow lines, the top and bottom functions are always the two different functions, right? Compared to orange, where at some point it's the same function. So if we go ahead and match this with the answer key, it'll be this guy right here. So that'll be option C. All right. Let's go ahead and move on. Question 8. So again, sketching the region. Same deal. So we got x is equal to 4 minus y squared, and x is equal to y squared minus 4. So this is testing if you understand how to graph this. Oh, does it say to find the area? Oh, I see it. I see it. Okay, I'll go back. We'll go ahead and do that first. So it says, yeah, find right here. Find the area of the region. So if I remember correctly, we had y is equal to x squared minus 2x, and then y is equal to 2x, right? These are our two lines. Okay, so, and then we knew the graph is like this. Okay, so if we were to find the area now, area is equal to the integral of the top function. Oh, wait a minute. With respect to x, with respect to y. I think I mixed up my respects incorrectly. Yeah, we want it in with respect to x. Sorry, yeah, vertically is with respect to x, horizontally is with respect to y. So I messed this up. This is supposed to be dx. Yeah, so vertically like this is all with respect to dx. And you can sort of think of it, if we have a function in terms of x, what is your output? Your output's a y, right? So that's the way you can sort of think about it. If you want it vertically, what your output should be y, so your input should be x. And if you want horizontally, your output is x, so you want your input to be y. Yeah, so that was my fault. I mixed it up. So you want to do it with respect to x because we're doing it vertically. So vertically is with respect to x. So in order to find this area of the region, it's the top function minus the bottom function, right? Very straightforward. The integral of the top minus the bottom with respect to x. This is, again, vertical. So if we go ahead and do this, we can see that the top function is the straight line. So our top function is 2x. And our bottom function is the x squared minus 2x. So don't forget to put this parentheses around it so that you don't forget you have to distribute this negative sign later on, right? And if we remembered, when we set the equations equal to each other, we found that the points of intersection were from 0 to 4, right? So our integration bounds will be from 0 to 4. So here's our integral. That'll calculate the area. So let's go ahead and zoom through this since we're just calculating an integral. So if we distribute the negative, we'll get this guy right here, which can be simplified further to the integral of 0 to 4. Why did I put 2x there? This is supposed to be 2. So it'll be 4x minus x squared dx. If we go ahead and simplify this out now, we'll get 2x squared minus 1/3 x cubed. And we're integrating this from 0 to 4, right? So if we go ahead and punch that in, that'll be 2 times 16 minus 64 over 3. That's not a nice number. Let's see, that's going to be 32 minus 64 over 3. That's equal to 96. 32 over 3. Is that correct? Is that what everyone else got? All right. Looks like that's correct. Yeah, so if you guys have any questions on how I integrated this, because I know I sort of skipped a few steps there, but it's just power rule. If you go ahead and do where you increment the power, divide by that power, it'll simplify all to this, right? So any questions there? All good? All right, so that's the area of this region right here. So let's go ahead and move on to question 8 then. Yeah, let's do this. So right here we have equations in terms of y. So we have x is equal to some y equation. If you guys are unsure of how to graph this right away, like when it's x equals something in y, feel free to just change it into y in terms of x, and then make sure you just graph it correctly that way. But the way you can sort of think about it is, well, we know y squared is going to be something squared is a parabola, right? And the sign in front of it just tells you if it's upwards or downwards. So if we sort of quickly try to graph this, here's the x-axis, here's the y-axis. So x is equal to 4 minus y squared. So this plus 4 means that we shift it rightwards, or if you turn your head sideways, so x is the vertical axis, upwards 4. So this is 4 right here. And if we take a look, it's a negative y squared. So that means it's supposed to go downwards, or leftwards rather. So towards the negative x's. So our parabola sort of looks like this for this first equation. So let me go ahead and label that as x is equal to 4 minus y squared. And then for the second equation, it's the same thing mirrored, right? So we just go back to the negative 4 in the x direction, and then it's a positive y squared, so it goes towards the positive x's, and it'll go like that. It's supposed to intersect here and here, but I drew it poorly. There we are. Right, so it's supposed to look something like this, and it intersects at, if you were to set them equal to each other, we know they intersect at at y equals 0. No, sorry, at y equals 2 and negative 2. Yeah, so we've got y equals 2 here, and y equals negative 2 here. So taking a wild guess, with respect to what variable do we integrate this to? dy, right? Because we're going to do it horizontally. So we're going to do it with respect to dy. And usually a big hint is if they give it to you, like an x equation equals some y equations, that might be a little hint that you might want to do it with respect to y. But again, don't always assume, because some of the trickier problems, they do that on purpose to throw you off. But in the easier sections, yeah, it's straightforward. So we're gonna integrate with respect to y, and let's go ahead and do that right now. So we got the integral, or the area is going to be the integral from, let's see, -2 to 2, right? That's our y bounds right here. Whatever integral you're integrating to, so whatever dy or dx, whatever d variable it is, that's where you, in order to find your bounds, you want to look on that axis. So if we're integrating in terms of dy, we want to look on the y-axis for where, from where to where do we want to go? And it's from -2 to 2. That's where everything fits on the y-axis, right? So if we go ahead and integrate it out from -2 to 2, what would be our top function, or quote-unquote top function, and a quote-unquote bottom function? Exactly that, right? So it'd be what 4 minus y squared, sorry, minus the quantity y squared minus 4. And if you ever integrating in terms of y or horizontally, you can sort of replace top and bottom with right minus left, right? Because the rightmost is equal to your top, and the leftmost is equal to the bottom. There's a little things you can switch it up if you need to, whatever makes you remember easier. And if we go ahead and quickly speed through this, let's see, the integral from -2 to 2, so it'd be 4, must be 8, sorry, it'll sum up to 8 minus 2y squared, I believe, dy, and then we go ahead and integrate that. So what do we got here? Got 8y minus 2/3 y cubed from -2 to 2. Plug everything in. So if we plug in 2, we got 8 times 2 is 16 minus 2 cubed is 8 times 2 is -16. -16 over 3 minus, now plug in the -2 version. If I can write. So then we just go ahead and add that. That's 32 minus 32 over 3. 96 minus 32 is 64 over 3, right? I think that's the answer, if I did my math correctly. If I messed up somewhere in the algebra, please let me know. I make mistakes too. So that's the straightforward way. Any questions? Any comments? Did I do something wrong? I totally could have done something wrong. Well, so I sort of, if I read the sort of elementary steps, because the 16 minus -16, that'll be 32. So to add them together, yes, I multiplied 32 by 3 over 3. And that's how you simplify it that way. But yeah, what I wanted to bring out, does anyone notice something special about this graph? Is there, or if we try to find the area, is there any shortcut we can do? Symmetry, right? This is perfectly symmetric about the x-axis. So if we wanted to, we could definitely just break this in half and write our bounds from, let's say, 0 to +2, and then just multiply the integral by 2 that way, right? So the area is also equal to 2 times the integral from 0 to 2 of 4 minus y squared minus, I'm going to run out of space, right there, right? So if you recognize that there is symmetry about some point or some axis or some line, then you could integrate it about starting from that axis of symmetry to one of the ends and just multiply that integral by 2. That usually makes it a lot easier. And most of the time, if you do get symmetry with your problems, they'll make it symmetric about either x equals 0 or y equals 0. And if we remember how when we plug it into the integral, that'll just means you only need to plug in one of the numbers, because anything plug in 0 is very simple, right? So I would have preferred to done, I would have done it this way, because it makes your math easier. You don't have to deal with all these fractions down here. You probably only need to deal with it once. But yeah, either way will give you the same answer. Stick with what you're comfortable with. Although there's some shorter methods, stick with what you know better, right? Don't try to force yourself to do something that's just because it's quicker when you're not that comfortable with it. So in terms of the graph, I think it's this one right here, right? Pretty sure it's this one, the second option, all right? So yeah, let's go ahead and move on if there's no questions on that. If there are questions, again, just let me know. I can go back. Don't be shy. Question 9. Sketch the region enclosed by the curves. Probably find the area again, right? So what we got about, I started at 11. I technically have to go up till 12:30. We have about 30 minutes left. I'm going to start skipping some because these are all very repetitive, and hopefully you guys are more confident on these, at least on the process. It's all very similar. Let's see. Yeah, there we go. Let's start doing volume problems. We have to start rotating. Okay, so number 10 is find the volume of the solid, rotating the region bounded by the given curves by the specified line. Okay, so here's the curves. We're rotating about the y-axis. So real quick, if we're rotating about the y-axis, that should give you an immediate hint at what is our d variable be? What are we integrating with respect to if it's the y-axis? Very good point, whoever pointed that out. It depends on the method you're using. Let's assume we're going to be using washer and the cylinder one, not cylindrical shells, dy, right? So although you could use cylindrical shells, let's not use that yet. I think there'll be a problem later, correct me if I'm wrong, that specifically tells you to use cylindrical shells. Yeah, so we're going to use the regular washer method, or I forgot what the name is when there's no hole in the middle. Disk, thank you. We're going to use the disk method in this case. We'll do washer method when they say to use washer method, but again, if you think washer method is easier to you can use it totally here. It'll give you the same answer. So there's multiple methods to get the same answer, but for now we're going to use disk method because we'll ignore washer until we need to use washer. So we got y squared. If we start graphing this, y is equal to x squared. Sorry, and then we have a straight line. Okay, I can't write right there. The straight line is y equals to 4x. So our region is like this little thing right here. We're rotating about the y-axis. So if we sort of sketch out the region, it'd be something like this, right? So this is technically a washer, right? And who can tell me the formula? What is the formula? I'm missing some parts on both sides, but who can tell me the formula for washer method? Mm-hmm. Sure, yeah, outer minus inner. So I'm going to use big squared, right? Outer squared minus inner squared, right? And then d, in this case, we're doing y, so we're going to do dy, right? And I'll let the outer be the bigger r, so the bigger radius squared minus the smaller radius squared, right? That's the way I learn it. Hopefully that makes it easier for you to remember it. Remember, it's this. This is not the same. It is not the same as this. Do not mix these two up. You will get a wrong answer if you do this method. This is wrong. It is not the difference of our big R minus smaller or outer minus inner, that difference squared. That'll give you the wrong answer. So make sure you square each radius and then subtract, not the other way around. You will get the wrong answer if you do this. These are not the same. So with this formula, which function would be? Oh, actually, before we do that, we're integrating with respect to y. So what do we need to do with our equations? Flip the variables, right? So let's go ahead and flip that. This will give you x is equal to square root y, and this will give you x is equal to y over 4, right? And now if we go ahead and plug everything in, which one is the bigger r? Which one is the outer radius or the outer function? Root y, right? It's the one on the right, most right. So it'd be root y squared minus y over 4 in parentheses squared dy. Now before we move on, we need to find our bounds. And like we said before, in order to find the bounds, just set the equations equal to each other. So you could do that in either variable form, but since we want it in terms of, we want the y variable, let's do it like this. Square root y is equal to y over 4. Well, we can square both sides, right? If we square both sides, this will give us y squared over 16 Now we get 0 is equal to y squared over 16 minus y. Pull out a y. Let's see, y over 16 minus 1. And then if we simplify this, correct me if I'm wrong, your y bound should be from 0 to 16, right? No, no dumb questions.
Okay, this looks bad to me. So can I just set in the very beginning? Because I always find my limits first. I don't know why. I'll do it in like the right respect to them. So I just set both equal like x squared equals 4x, and then plugged back in whatever I got for x.
Totally fine.
It works every time.
Yes, it works every time. They're both perfect, and sometimes I do the same thing. I usually find the limits right away. So you can totally just set x squared equal to 4x. Find your x's that way. What's that? X squared minus 4x is equal to 0. So that's x minus 4. So x equals to 0 and 4, right? Yeah, and then just plug it into either one. Totally works that way. Yes, you have to remember what variable you want. Yeah. As long as you remember that, you're good. Again, several different ways to do all the same problems. Pick your favorite, right? And yeah, so either way, we get the y bounds from 0 to 16. So our integral is pi times the integral from 0 to 16 of y square root of y squared minus the quantity y over 4 squared. So if we go ahead and I'm going to draw this down here, it'll be pi integral 0 to 16. Square root squared is just the original thing, minus, that'll be y squared over 4, right? 16 rather. And then dy. Let's simplify this out. What do we get? It's pi times 1/2 y squared minus, okay, this could be interesting, y cubed, and this will be 1 over 16 times 3, right? So what is that? That's 58? I'm messing, no. It's 48, right? Yeah, so 16 times 3 is 48. I'm going to erase that and put it right there. And then our bounds are from 0 to 16. And now, if you plug in 0 to any of these, it'll just be 0, so we can ignore that. We'll just plug in 16. So all we have left is 1/2 times 16 squared minus 1 over 48 times 16 cubed. Now, and if you guys are taking your exam on WebAssign, you can leave it like that. WebAssign does not care if you simplify it. So I'm going to leave it like that. If you want to calculate it for me, by all means. Let's see if I can do that real quick, actually. 16 squared is 256 over 2. Okay, yeah, no. Oh, no, wait a minute. Because we have 16 cubes over 48. 48 is 16 times 3. So this is now squared. So this is, okay, this is pi times 256 over 2 minus 256 over 3. Da, da, da. This would be 256 pi over 6, right? I think. And then you can simplify that further by dividing it by 2 or something. So what's that? 128 over 3 pi. I think that's the answer. That is the answer? Perfect. Okay, I can do math. Great. But yeah, so the more important process there to remember is just this formula. The formula, as long as you remember the formula, and then you remember what each variable stands for, you're golden. Big R or your outer function, small r or your inner function, make sure it's r squared minus r squared, not r minus r. That whole thing's good. Very different answers. If you're going to do disk and washer method, if you're rotating about a y-axis, it's dy. If it's an x-axis, it's dx. Make sure you change your functions so that they're in the right variable form. And we'll see later we'll talk about what the difference is with shell method later. So we don't need to worry about that right now. But yeah, any questions on this problem? All good? All right. So we'll go ahead and skip right past here. What is this? Okay, yeah, we're gonna ignore those. This is another type of problem with it. Are all the rest of the problems just gonna be volumes, or is there like any unique ones? Arc length? Okay. Did you guys want me to do another volume disk washer method, or do you guys want me to sort of skip to the cylindrical shell method, or how do we want to go from here? Because we're about 27 minutes left, and I want to make sure we get what we want, right? So if you guys want to start looking towards the end of like the problems onwards, start looking at what problems you really want to cover. I can go ahead and skip to that because I personally think we can go ahead and skip 11. It's about the same thing, except if you do washer and or disk thing, you're gonna, in this case, it's the x-axis, so you're gonna do dx, right? That's the only difference really. You just gotta, and then recognize which functions are in there. Is it all right if I skip this and go to another one?
Yeah, can we do a shell problem?
Shell's problem, right? Do we know what number a Shell's problem is? 14? Okay, let's go ahead and skip to that. Wait, real quick, what's 13? Oh, this is 12. Oh. Okay, I'll come back to 12. A Shell's problem first, but I want to do 12 as well because this one's going to be a little interesting because there's a little offset that we need to cover. So you said 14, right? Skip 13. Here, 14, we've got a cylindrical shells method. Okay, yeah, and they just want us to find the volume. Okay, so we have, first things first with all of these problems, always graph. Always sketch what's going on. And in this case, we have y equals 0 and x equals 0 are the x and y axis. And y is equal to 6 minus 3x. So we start at 6 here. We go down and I technically am cheating, but if you were to plug in, if you were to set this equal to 0, you'd realize that this is 2 right here, right? So, and then it's bounded by the y and x axis, so it's this triangle region. And we're rotating about -1. Actually, we might not need to go back to do 12. This covers it in here. We're rotating about, oh, no, x equals -1. Sorry, wrong direction. X equals -1 is right here. So here's our sort of axis of rotation. Let's sort of get rid of this right here. This is distracting. And we're rotating it this way. So we're doing cylindrical shells method. So looking at this, the axis of rotation is kind of like the y-axis in a sense, right? Just shifted a bit to the left. So it's kind of like the y-axis. That should give you a little hint. What is our respect? With respect to what variable? It's d what? Dx, exactly, right? If you ever have an x equals equation, and x equals that, and that being the axis, if the axis is ever x equals, it's always dx in shells, right? Shell method, it's the same as the axis. Oh, sorry. It's the same as the x equals. If you give you y-axis or x-axis, then you flip the variables. But try to simplify that in your head and make the most sense of it, because it can get a little confusing. But we're going to be integrating with respect to dx. And like what I like to think about it in this case, to figure out what your bounds are, whatever respect variable you're doing, always immediately look at that axis on the graph. So dx, so look at the x-axis. I know my shaded region starts from 0 to 2. So our bounds will go from 0 to 2, right? So there we go. Immediately get rid of the question of what the bounds are. And now the cylindrical shell's formula is 2 pi integral from a to b of the radius times the height, right? Or in this case, the difference of the radiuses times the height. And then in this case, it's dx. So let me replace this with r minus r. I think that's correct, right? The bigger radius minus the smaller radius. Or I might be thinking of this wrong. Let's keep it as this. We'll analyze it and we'll get to the right answer. So in case you guys didn't know of it, if you want to think of it conceptually or geometrically, all cylindrical shells are, if you think of like a soda can, all it's taking is the walls of the soda can infinitely until you fill up the entire thing. That's how I like to think of it, and that's how I always remember. It's going to be, how do you find the wall of a cylinder? It's the circumference times the height. So 2 pi r is the circumference, and h is the height, right? So in this case, since we're rotating about this way, if we sort of get, let me get a green thing. If we sort of draw that sort of wall, here's our sort of base of the cylinder, here's the height of the cylinder. So the height of the cylinder is in the y direction, so we need an equation for that, right? So our equation for height is going to be y, right? If I remember it correctly, isn't it just going to be, we can sort of rewrite this as xfx, right? Is that what you guys have as your notes instead? Something similar like that? Except, oh, okay, the radius will be slightly different. It's not x in this case, right? So the height will always be a function with respect to x if you're doing it dx, or fy if you're doing dy. But the radius, you always have to account for something. In this case, let me get a green pen. Start from the origin. Here's what I like to do. Start from sorry, not the origin, the axis of rotation, and pick an arbitrary point on the graph right here, right? So if we were to plug in, our x's go from 0 to 2, right? But if I look at point 0, the radius is not 0, right? The radius, I have to account for this missing space right here, right? And that's 1. So the radius is actually going to be what? 1 plus x, exactly, right? 1 plus x, or x plus 1, however you want to write it. And it's that way, so that if at every point, so a good way to think about it is to figure out what you need to add or subtract by, start from the axis of rotation. Let me get my pen out again, the green pen. Start from the axis of rotation and go to each of the endpoints. And then they both should be added or subtracted by the same amount to get the correct radius, right? So don't pick the arbitrary point. I don't know why I said that. That's not as useful. Do the endpoints because it's easier to visualize that way, right? Because I can see that the radius from this endpoint is 1, and the radius from this endpoint is 3, but my bounds are 0 to 2, so that means I added 1 to both, right? That's the sort of logic you can use to help simplify this problem down a bit. So going along with the actual calculating the integral now, we can go ahead and plug everything in. So it'll be, the volume is going to be 2 pi from 0 to 2 times 1 plus x times the f of x function, which is going to be this guy right here, 6 minus 3x, all dx, right? And if we go ahead and simplify this out, what do we get? 2 pi, 0 to 2. Foiling this gets you, I'm going to try to jump ahead a bit so we can save time. This will be negative 3x squared plus 3x plus 6, I think. Yeah. So this is the integral of the quadratic formula right here, a quadratic equation rather. And finishing this, we get 2 pi, let's see, oh, that's a 3 right there. That's nice. So this would be negative x cubed plus 3 over 2x squared plus 6x, and then from 0 to 2, right? You can realize that 0 doesn't do anything. It'll just be 0. So you can just plug in the 2. And we're left with 2 pi times negative 2 cubed is 8 plus 2 squared is 4. Divided by 2 is 2. So 2 times 3 is 6 plus 6 times 2 is 12. And this becomes, let's see, that's negative 8 plus 6 is negative 2. Negative 2 plus 12 is 10. So it's 10 times 2 pi, or the final answer, 20 pi. All good? Does that sort of process make sense? Does those tips help like consolidate all that information? Definitely the thing that you always need to watch out for these types of problems is if the radius is offset by some shift, right? Always watch out for that and account for that. Otherwise, you'd get it off by like a slight number and that'd just be frustrating. But yeah, another little tip to check or to check if you know you're wrong. If you're doing a volume or an area problem, okay, not an area problem, I'll take that back. If you're doing a volume problem and you get a negative answer, that's how you immediately know I messed up somewhere. Let me go back and check. You cannot have negative volume. Technically, you can have negative area. It just be below the x-axis, but we're not going to talk about that. But yeah, just a little tip there. And for now, I don't think we need to do 12 because 12, I think, is also an offsetted radius problem. Just do it in either shells or wash or disk, up to you. It's the same idea. Just make sure if you have an offsetted radius, you always add that to the correct radius, right? Always watch out for that. If we have time, I can try to do that. But did anyone have any other problems we wanted to do? I'm looking at a copy as well to see what's my 18. Let me see what does 18 look like. So I have another document pulled up to the side here. My 18 is, oh, surface area. Oh, that's 19. Sorry. No, I'm reading the wrong one. 18's find the exact length of the curve. So you guys want to do arc length? Oh, okay. Gotcha. That's what you meant. The red number changed. So mine's two. Oh, that's not nice. Okay. Well, let's give it a shot. Okay. So, who can tell me the arc length formula? So L is equal to, I'm already wrong here. L is equal to what? Assuming we're doing it with respect to X. Hmm. Okay, so I'm going to write it as F prime of X. Yeah, dy dx. This is the same as dy dx. You're correct. Is that it? Oh, squared, right. Is that really it? Or was it not? I might have studied the wrong formula. Let me double check. Uh, arc length formula. I just want to double check that I do have it. Integral. It is just that. Oh, okay, yeah. I did my practice problems completely wrong. Okay, yeah, it's just straightforward as that, right? So in this case, this y equation is our f of x. So let's first, and this is our a to b. So let's first figure out what the derivative is, or dy dx, right? However you want to write it. I like writing it as f prime because I don't like having to write a fraction. So if we're to find the derivative of this equation, we're going to use some chain rule here because we have this power equation on the outside and this quadratic on the inside, right? So doing power rule, it's the derivative of the outside, so that's the power first. So derivative of the outside, we bring down the power, so let's bring down 3 over 2. We write the exact same thing in the inside. We minus 1 from the power. 3 halves minus 1 is 1 half. And then that's the derivative of the outside. Now we have to take the derivative of the inside, right? And multiply it. So the derivative of the inside is the derivative of 1 plus x squared. That'll be 2x, right? And then from there, simplify this all out. What do we get? Well, these cancel out. 2/3 and 3/2 cancel out. All we're left with is 2x square roots of 1 plus x squared, right? Because the exponent of 1 half is just a square root. There you go. That's actually not that bad. Except when we plug it in, it's going to be a little bad. Let's see what happens. So the arc length is from 0 to 2 of the square roots of 1 plus, okay, before we plug it in, let's take a little step right here. What is f prime of x, or dx dy? What is this whole thing squared? So 2x, so we got this basically. We got 2x, the square root of 1 plus x squared, all of that squared, right? So because everything's multiplied, you have to distribute the power to everything. So 2 squared is 4, x squared, and then a square root squared is just going to be the inside, right? So this is what we're left with. 4x squared times 1 plus x squared. We can simplify that further to 4x squared plus 4x to the fourth, right? And I see. This is actually going to be a really nice solution. Um, so I plugged in the f prime squared. Again, I solved for f prime squared outside rather than inside. So now we have right here is we have 1 plus 4x squared plus 4x to the fourth within that thing. And uh, if you recognize this, this is actually a really nice quadratic because it actually is a perfect square. It is 1 plus 2x squared, all of that squared, right? And that's a sort of trick. Usually, if they give you something like this, usually it'll simplify out to something nice. Sometimes you might need to use tricks like completing the square. Can you do that in this case? No, you can't complete the square inside the square root. No. Yeah, you might need to do some other tricks, maybe like U sub sometimes, pull out some factors. But in this case, hopefully you guys get something as nice as this, where it's a perfect square. The square root of something squared is just going to be the inside. So really, it's the integral from 0 to 2 of 1 plus 2x squared. And that is very straightforward, right? That'll be, what is that? X plus 2 over 3x cubed from 0 to 2. 0 will make everything 0, so it'll be 2 plus 16 over 3. What is that? 6, that's 22 over 3. That's the length, I believe, if I'm doing my math correctly. I think I am. I really think I am. Let me pull that up a bit. Yeah, I think I did that correct. But yeah, that's arc length for you. As long as you remember the formula and you take the derivative and square it on the outside so that you inside the square it's a lot cleaner, you should be fine. Definitely the difficulty in these types of problems is once you do plug everything in. Oh, the highlighter tool is not working. That's a shame. Definitely the thing that you need to watch out for is whatever's in the square root. Hopefully, again, you got to really hope that your professor is nice enough to give you something that simplifies out nicely. And I doubt they do something that would not simplify out. So there might be some tricks. Let me while you guys are looking at that real quick, let me see if I can find one with a trick like that. No, that'll be very straightforward. Yeah, no, it doesn't look like there will be any. Yeah. All right, so we've got about 10 minutes left. Um, there is a surface area problem. There is a centroid problem. Which one do you guys want to cover first? Because I might not be able to get to both. I could try if you guys are okay with me speeding through one of them. Centroid or surface area? What's your preference? Doesn't matter? Okay, we'll go in order. We'll do surface area. Um, oh, I know. I didn't get it wrong. I was mixing it up. Okay, who can tell me what the integral for surface area is? Sorry, the formula for surface area. All right, this is what I mixed up. I didn't do it wrong. I was finding the surface area. Okay, yeah, and that's all it is. If you can remember that formula, it's just plugging everything in again, right? So looks like in this case, they're gonna break it by parts for you, so you don't need to worry about that too much. But all it is, if we were to do this problem real quick, 2 pi, well, the bounds are given. That's 0 to 3. We're doing it in terms of x. F of x is x cubed. 1 plus, well, let's first take the derivative of that. What is the derivative? That is 3x squared. So the derivative squared is 9x to the fourth. Okay, that comes out nicely. So it'll be 9x to the fourth over here inside. And it looks like that's what you plug in there. And now you actually calculate it. So if we actually calculate this, okay, this is going back to what we did in the beginning. What method would you want to use here? U sub, right? Because we see an x cubed on the outside and x to the fourth on the inside. So we're going to let u equal the entire thing inside the square roots. U is equal to that. du is equal to 36x cubed dx. So 1 over 36 du is equal to x cubed dx. And let's see, we got 2 pi integral from... Do you guys like changing your bounds to the new variable, or do you go back to x at the end? I like to change my bounds too. Okay, because I know some professors teach it just do it at the end. I don't like doing that. So if you plug in 0 to this, we get 1 plus 0, so it's from 1. Plug in 3, that's 1 plus 9 times... Okay, what is 3 to the 4th? That's 9 squared, 81. 81 times 9 is 279? No, 81 times 9 is 729. 729 plus 730. Nice number. There you go. So lots of practice to be able to do that in your head. And then you just substitute everything in. The x cubed and then the dx substitutes with, well, actually, let's do this first. The square root of u, and then the x cubed and the dx become 1 over 36 du. So let's actually bring out the 130, so 1 over 36. So we get 2 pi divided by 36. We can simplify out that to be pi over 18, right? Integral from 1 over to 730 of square root u du. Let's actually change that. Let's not write square root. Let's write 1/2, right? Power of 1/2. It's easy to see. And then from here, very straightforward power rule. This will be u to the 3 over 2. So this is 2 over 3, right? And then from 1 to 730. Oh, this is not a nice number at all. Yeah, this one, don't worry about simplifying it because there's no nice way to simplify this. You'll get 2 over 3 times 730 to the 3 over 2 minus 2 over 3. If you want, you could actually bring out the 2 thirds out so that you get what is this? Pi over 18 times 2 over 3. What does that simplify to? This cancels out to 9. Okay, so you get pi over 27 times 730 to the power of 3 over 2 minus 1. Right? And I'd leave it at that. Don't even bother trying to simplify that out because you can't. It's not nice. But yeah, that is the surface area. Again, it's kind of, the equation is very similar to arc length if you think about it. Right? It's just you're multiplying the fx and 2 pi in. So you can, very easy to, if you can remember arc length, you can probably remember surface area. Just remember the individual added parts. And again, it's just plug and chug. That's all it always is with these integrals. Just plug it and chug it. That's all it is. So let's go ahead in the last 5 minutes. Let's see if I can figure out how to do a centroid problem. Who can real quick tell me what is the formula for x bar and what is the formula for y bar? Like that? And now how do we find these two parts now? Yeah, it's rho. Yeah. All right. And how do we find my and mx? All right. And lastly, what is mx? Mm-hmm. Yep, that's it. And again, this is all just plug and chug. Are you guys allowed a formula sheet on your exam? Perfect. Don't even bother remembering this. I was like, I can't even remember this. So let's see what we got here. Now, in this case, we got to sort of figure out our functions a bit. Our top function is this line right here. They have it right here. Why did they write it like that? This is y is equal to negative 2x plus 8. And then your bottom function, it's just the x-axis, so y equals 0, right? So your f function is this. Your g function is this. So if we look at all the parts where g is, that's just 0, makes it way easier, right? So let's first calculate our big M. Big M is rho from, what's that, 0 to 4, because we're doing it in terms of x. Gx is just 0, so we just look at fx. So we're just taking this integral. What is rho? Did they even give us what rho is? Or are we just assuming it's 1? No, it cancels out, doesn't it? Yeah, it cancels out. Okay, we'll just leave it. Okay, yeah. So rho will cancel out, so we can just leave it there for now. M becomes, what is this? Ooh, negative x squared plus 8x from 0 to 4. 0 makes that 0, so we just plug in 4. That's negative 16 plus 32, so it's positive 16. 16 rho, right? That's what M is. Now let's go ahead and calculate My and Mx. My is equal to rho integral from 0 to 4 of x. Again, gx is 0, so it's just x times fx. So it's x times 2x plus 8 dx. Simplify this further. Rho is 0 to 4 of negative 2x squared plus 8x dx. This becomes rho of negative 2 over 3x cubed plus 4x squared from 0 to 4. Oh boy. 4 cubed is 64 times 2 is negative 128 over 3 plus 64. This is all times rho, by the way. So 64 over 3 rho. Perfect. Okay, that's my, and then mx is equal to rho over 2 times 0 to, from interval from 0 to 4 of fx squared, right? Because gx is 0, so 0 squared 0. Fx squared, so this would be the line, oh, negative 2x plus 8, that whole thing squared, dx, which is equal to the rho over 2, integral 0 to 4, 4x squared minus 32x plus 64 dx. That becomes, well, what does it become? That's a good question. 4 over 3. Okay, hold up. You can actually pull out something from here. All of this is divisible by 4. I'm going to pull out a 4. So this is times 4, the integral from 0 to 4 of x squared minus 8x plus 16, right? And then simplify that again. So 4 divided by 2 is 2. So 2 rho times 1 over 3 x cubed minus 4x squared plus 16x from 0 to 4. And how do we solve this quickly? There's no way to solve it quickly. 16 times 64 over 3 minus 64 plus 64. Okay, that actually comes out nicely. 128 over 3 rho. And now that we have every individual part, I think I did this correct. I'm just assuming I did it right. X bar was my over big M, which is my was 64 over 3 rho, all over, what was big M again? 16 rho. God, I should, 16 rho, okay. And the rows cancel out, so all we're left with is 64 over 3 times 1 over 16. This cancels out to become 4 over 3 for x bar. And y bar is equal to mx over big M, which is equal to 128 over 3 rho all over 16 rho. Rows cancel out. This is equal to 128 over 3 times 1 over 16. That actually, this, what's that? 64 times 8, thank you. And this becomes 8 over 3 for y bar. And that's how you do centroid. Lots of work for just a point. But yeah, so it's unfortunately we're out of time, and luckily there's only one more problem after that. So yeah, so I guess some general test taking tips is usually what we do at the end of these review sessions. Here, let me stand up so I can actually see you guys' faces now. So first of all, thank you guys for coming. First review session in person for a year or something like that. So congrats on being the first. Yeah, just to remind you guys that if you guys wanted to go back and look at the problems that we did, especially you two for the problems that you guys missed in the beginning, this whole review session was recorded and will be uploaded to our YouTube channel. Just look up UNR Math Center on YouTube. You'll find it. It'll be uploaded this afternoon, maybe late this evening. So again, that goes for you guys too if you guys want to review what we covered earlier. General test taking tips. You guys' exam is tomorrow, I'm assuming. Oh, yeah, that's right. It's you guys have a while. It's Memorial Day, 3-day weekend. Hooray! If you guys do study, try not to study the night before, get some sleep, eat a proper meal, all that good stuff. But yeah, that's all I have for you guys today. So thank you guys for coming. Yeah, no worries. Let me go ahead and stop the recording.